In the last talk, as we discussed about the deployment and development and deployment of LLM-based Q&A system, there are various challenges such as result accuracy and production monitoring and scalability. So in our next talk by Venkatesh and Suman, they will shed light on these challenges. Over to our speakers. A few details about our speaker. Venkatesh has over 12 years of experience in the area of computer vision, machine learning and NLP, embedded AI and analytics. He has delivered solutions across a wide variety of industry and shares his expertise with community by speaking at conferences. Some of the conferences he has attended is AI Summit London, Machine Learning Developer Summit in Bangalore, and AI Expo at Santa Clara, USA, and so on. And our next speaker and our other speaker, Suman Paul Chaudhary, brings over 7 years of experience in computer vision, machine learning, and deep learning. He's a passionate researcher in data science and has contributed to communities' knowledge pool, speaking at conferences, and conducting workshops. Over to our speakers.
Okay. Hi everyone. Good evening. Glad we made to the last session of the day. I'll just start off by saying this. Kartika, Shruti, Sibin has talked about the good parts of the RAG. We will talk about the not so good part of the RAG because we are talking about the production challenges, right? So now, since we are talking about the production challenges, this talk would focus more onto what are the challenges or what are the factors, right, that we need to take into consideration before we take any application, be it RAGs or LLMs, to production, right? What are the things that we need to evaluate, be it in terms of the metrics? Do we need to evaluate before putting these things to production? These are the factors that we'll look into. Let's talk about the other perspective. Let's say if we want to deploy not an RAG, but also the LLM, there are various factors that we need to consider, be it factors regarding to the cost, factors regarding the latency, the throughput, which particular model should you choose, whether it's an open source model, whether it's a proprietary model like OpenAI, what is the cost associated with it. All the things that are related to production, we'll rather have a broader look into it, right? We have ensured that we have put up a lot of materials into one particular talk so that you don't have to look otherwise. All of the things that you need to take into consideration while before putting into production, this is the one place to be, right? So with that said, I'll talk by starting off with the 4 major areas in which the industries are focusing right now with respect to the generative AI, right? The first thing that we generally see that a lot of companies that are building up with the help of generative AI is document processing and information extraction, right? So given an example, I'll rather give up an example. Let's say you have a lot of medical documents, right, of the different patients out there, information related to name, address, blood group, phone number, and every other things. Can we automate in such a way that we would rather extract information out of it through the help of generative AI and put that in the form of a more of a structured manner, right? So this part of pipeline is what we call it as a document processing and information extraction. A lot of companies are doing work on this particular domain, right? There is another domain which a lot of earlier speakers have talked about today called the RAG, which will be going into the much more detail about what are the things that are need to be considered for production. But one particular domain is knowledge base and question answering, right? The other part of the where the industry people are rather focusing upon is building up conversational agents, right? Now, what is conversational agents? Let's say you are in an logistics industry, right? You want to build up a particular conversational agent related to the logistic industry, right? So you would rather make up a custom bot which is focused more onto the logistic industry, right? You want to build up a customer support agent. So you would rather put up or make up a bot which would rather focus just on the customer part, right? A lot of companies are focusing on building custom-made solution conversational agent. The last part, or like one major part that I see, right, like companies like Zapier, right? You would rather heard the name, or you would see a lot of YouTube videos, ads. What they do is this, what they call it as a workflow automation, right? You have a lot of emails that you have in your inbox. When you are in a business, you will have to read up a lot of emails. What if you can put all those email inbox, all the emails into the generative AI pipeline? It would read up the email. It would rather put up a suggestion to your email accordingly, and makes the entire workflow automation very seamless for you, right? This helps you to accelerate your business accordingly, right? So these are the four broad areas on which industries are focused upon. These are not inclusive, exclusive. There are other areas as well, but broadly industry people are focusing on this, right? I will not go into the details of RAG system again, because a lot of speakers have talked about it. Just to give you a very brief about what RAG system is about. Ideally, we have three things. One is the data ingestion pipeline, where we have a chunk of data. You take up this chunk of data, take up important information, convert it into meaningful chunks, as you rightly saw in the earlier talks. You convert that chunk into embeddings, and then you save that embeddings into the vector database, right? Then you have a data retrieval pipeline, right? We are talking about the RAG part. There you have a data retrieval pipeline where you have a query. This query gets converted into an embedding. This embedding does a semantic search on the vector database, and as a result, you get a relevant information chunks, right? And then at the last, you have a data synthesis pipeline, where this relevant chunks goes to the LLM. This LLM may be open source. This LLM may be a proprietary LLM. This goes to the LLM, where LLM takes up all the relevant information and the query, or the relevant chunks, curates that information, and presents the information in a much more meaningful manner, right? This is the end results that you get out there in the as a response that you see, right? LLM does a curation and gives you much more a synthetically curated answer for you, so that the end user can understand. Now the bigger question is, now that we know that the RAG pipeline is there, should we just deploy it? The answer is, like, building up demoable RAG system is quite different from building up production grade RAG system. There are a lot of factors that we need to take into consideration. What are the factors? First, we have to, as a ML engineering team, or the data science team, or the entire ecosystem as such, our job is to ensure that the pipeline is generating a high quality response. What do I mean by that? When I say pipeline, that means the RAG itself is an entire pipeline. It itself constitutes different parts of it. There is an ingestion, there is a retrieval, there is an augmentation or synthesis. When you combine them together, it's a RAG full pipeline. We have to ensure that those particular pipeline will generate a high quality response. What do I mean by that? It should not hallucinate, right? It should not make up answers and give you an answer on its own. We have to ensure the quality check is there. Apart from that, there was a question where we talked about the chunks, which I will give you an answer, better ways to do that. But there are ways where you can compare different RAG approaches, right? There can be various RAG approaches. We have to compare each of them, find out which one works best, and then ensure that only that part of the pipeline goes into the production, right? Third, we have to ensure that each individual, as I said, there is a full one end-to-end pipeline, and then there are sub-chunks to it, right? And information retrieval, augmentation, and each of those pipeline, we have to ensure that each of the pipeline also works well, right? And then we have to track the performance of the pipeline over time, as in, like we deploy or employ ML ops. We have to make sure that all of those performance tracking does happen over time, and you keep a track of it. Whenever the performance degrades over time, immediately you have to trigger an alarm saying that we need to cross-check the system again, correct? Yes, thank you. So, okay, So what are the challenges with RAG systems, right? We talked about all the good parts, now we'll look at the bad part of it. So what are the challenges with the naive RAG system? The first thing is bad retrieval, right? What do you mean by bad retrieval? I told you there are two components. One is the retriever, one is the generator, right? When we talk about bad retrieval, we are talking about the context or the relevant context given by the retriever, right? There are two things that we need to focus upon. One is the low precision. What do you mean by low precision? That not all the chunks that are retriever relevant. I'll give you an example. Let's say you upload a PDF of the Mughal emperors all throughout who has been reigning over India, right? Then you ask a question that where is Taj Mahal located and who built it, right? And then you get the answer that you get is Agra and Burhanpur and Shah Jahan. While you may say that some of you may say that the answer is correct, right? Agra, Taj Mahal is located in Agra, that's for sure. And it was built by Shah Jahan, that's also correct. But from where did the Burhanpur come, right? So if you go back, you would rather see into the retrieved chunks, you would see that Shah Jahan's wife was Mumtaz. She died in the city of Burhanpur. Because there is a relevance between Shah Jahan's wife, Mumtaz, when you did the information retrieval, one of the chunks also came into the top tier results. And that's why when they tried to generate a response, you also get Agra and Burhanpur, right? And that is the reason why I say low precision. Not all the relevant chunks that are retrieved are relevant. In this case, Burhanpur is not relevant for us. That's one use case. Second use case, low recall. Not all relevant chunks are retrieved. Now, if I say, when was Taj Mahal built? Answer is 1631. Shah Jahan built Taj Mahal in the memory of Mumtaz, right? But right after, before that particular Taj Mahal was built, there was a war between him and some Rajput warrior, which happened in 1601, right? But if the answer came out to be 1601, is because that all the relevant chunks that are retrieved are also not correct. So there are two things that you need to consider. One is the low precision that you need to cater into. One is the low recall, right? Now that is with respect to the retrieval part. Now let's go to the LLM, the synthesis part, right? What are the challenges that you face? Hallucination. Why hallucination? Because let's say if your LLM is, whenever you take up an LLM, it's already pre-trained on billions of other data that it already has in memory. Whenever it sees an unknown question, it tries to make up an answer. We have to make sure that those type of hallucination do not occur, right? Or irrelevance, right? Sometimes it just makes up gibberish answer, gives you an answer which is totally out of context. And the third is toxicity. There are at times when the LLM will generate a response which is offensive and harmful. So, in a, like Sibin also talked about the guardrails, right? Karthika also talked about the guardrails. We have to make sure that those things are put into place before we put this into production, right? These are the challenges with the NAG knife RAG system. So, what do we do at the first step? Before putting this to production, we go for the evaluation, right? So, what do you know? So, this diagram you saw earlier, right? There are two parts to it. One is the retrieval part, right? So, we need to do an evaluation on the retrieval part, right? So, there are various evaluation metrics that we need to consider, like context precision, recall, hit rate, MRR. If you just have seen this for the first time, do not worry. We are, we'll do that. Fine. Then we talk about the LLM generation, where are the different evaluation metrics, right? Like ROJ, BLEU, correctness, faithfulness, etc. These are the different evaluation metrics. Now let's talk about the retrieval part, right? We said we have to evaluate each and every individual part. We are talking about the retrieval part. I have taken up a very nice example. Just have a look at it. Now I have a data set of 10 movies, right? There are 7 superhero movies and 3 movies related to Pulp Fiction, right? The one that you see in red in color, Pulp Fiction, Shishong Redemption, and The Matrix, these are not superhero movies, right? Now an user ask a question as, give me list of superhero movies. the answer that it gets from the LLM RAG is this part, right? These 8 answers that you get from the LLM. Now, we talked about 4 different evaluation metrics. Let's look at it. What do we mean? Context recall. What it says, how many of the relevant results that exist are returned. So ideally, how many superheroes movies were there? 7. But inside the box, how many were returned? 1, 2, 3, 4, 5, 6. So 6 out of 7, that is around 92% of my relevant context was returned. So this is a evaluation metric that you can actually consider, right? These are quantifiable evaluation metrics, right? Let's talk about the context precision, right? How relevant the results returned are. So results returned, these are the 8 relevant results, and out of this, these 6 are the relevant results. So 6 by 8, which is around close to 80, 84%. These are my values, right? Or hit rate. What it says that out of the answer that we got, is there any relevant answer? Of course, there are 6 relevant answers. It's more of a binary answer as 0 or 1, right? Or MRR, mean reciprocal rent. What it says that, okay, you've given me the answer, tell me whether the first answer is relevant or not. The first answer is a superhero movie, Wonder Woman, so that's a relevant answer, right? So these are the 4 metrics that you generally use for retrieval, evaluation of retrieval pipeline, right? Now we come to the generation part, right? We talked about the evaluation of the retrieval. Now for the generation, now you have a generation LLM that has generated a text. You have some reference context. It says the breathtaking sunset covered the sky in a beautiful blend of colors, and this is the summary that LLM generated for you. The stunning sunset covered the sky in a mix of hues, right? Like the first metric that we talk about is Rauj, right? It says that how good the LLM is at summarizing, right? So if you look at these 2 sentences, it does a pretty good job in summarizing what it has meant to be, right? And this is what you generally do by ROG. It gives you a value between 0 and 1, right? We also talk about blue. Blue is another metric that tells you, okay, out of these 2 LLM summary and the reference context, how many words are overlapping? So if you look at it, sunset, covered, these are the sky, these are the words that are overlapping, right? It will give you again a quantifiable measure. Or meteor, right? What does it say? Is that given this particular 2 sentences, it gives you a comprehensive review by checking the synonyms. Now, breathtaking and stunning both mean the similar. If those 2 meanings are similar, it will give a higher score. Or we can also go for the LLM evaluation. LLM evaluation means faithfulness, like how correct the answer is, or like does it actually go for hallucinations or answer relevancy, right? So now just in case if you want to try out your experiments, click a picture of this, scan this, you will end up in my GitHub repo. There is a notebook into it. Whatever we have discussed, you can replicate those experiments, right? Perfect. So now, like since we have done the hard work, you don't have to do. These are all the frameworks that you generally have to, like you can use to evaluate all the frameworks. There is a LangChain, Lemma Index, Deep Eval, Ragas, right? I know Karun is not a big fan of Ragas, but if you use Ragas, you more or less would get all the scores out there, right? So my personal preference is Ragas. I can recommend it. It's up to you if you want to. But these are more of, if you want to take a picture, go ahead. But these are all the things that you would rather find in this evaluation metric, right? Perfect. So now, we have talked about the individual evaluation called the retrieval. We have talked about the generation. Now you stitch them together. Now you have the entire pipeline. Also, we have to check what is the end-to-end evaluation of the entire pipeline. And this is what I call it as a RAG triads. This is another evaluation metric, right? It gives you 3 things that you need to consider. And please focus on this, and because this is very important. You have a query. User asks a query. You get a response from the LLM, and you have a relevant context. Context means from where the source or the retrieve context that it has taken. There are 3 things that generally like RAG triads looks into. Answer relevance, whether the answer or the response is related to the query. That's one metric. Groundedness, whether the response is supported by the evidence or the retrieve context, right? And the context relevance, whether whatever it's retrieved, is it even relevant or not? So answer relevance, groundedness, and context relevance. If you ask me, of all the research that I did, context relevance is the most important. Why? Because these are the things that you, like if the LLMs are good, it will generate a response. But if the retrieve results are not good, there is no way you can get a good response. So for me, context relevance takes the bigger cut of the pie. Correct? Let's take up an example, which I personally did. So let's say you know about Andrew Ng, or what we say. She has uploaded a book called How to Be Good in a Career in AI. I have uploaded that particular book, right, and loaded that particular data set. Likewise, as Ajinka showed, I indexed the data set and created a vector store, right? Now, in the evaluation part, what I did is that I generated 11 set of questions, right? These are the questions that I generated. And if you want to take a picture of it. This is what you call it as a true lens. It's a package that helps you to generate those 3 RAG triads, right? Answer relevance, context relevance, and the groundedness, right? So when you run the true relevance package, you get this type of answer, right? Now, I would want your attention again, look at this particular score, right? The context relevance, as I said, which is the most important part, is the value is low, around 0.27. That means it has not retrieved good amount of content. Because it has not retrieved good amount of content, the groundedness is low, like 0.79, it's on a medium value. That means it is making up some answer. Because it is making up some answer, the answer relevance, though it's high, as a result, you could have just said, oh, the answer relevance is high, let's deploy it. But if you go back to those numbers, you will understand that because the context relevance is low, that means it has not got the retrieve content, correct content, right? Now the question is, okay, we did the evaluation. As a first manner, you said, okay, we did the evaluations. Is it good enough to ship it, right? So, not yet, right? We can still improve the performance. I'll come to your question now, right? We'll talk about RAG optimization. That's the next part of the talk, where the first optimization that we can do in RAG is sentence window retrieval. And that's a very beautiful concept. Look at it. If you have a question, what are the concerns surrounding the AMOC? Earlier, what we used to do is that this particular chunk will come over the 21st century, AMOC will likely to be correct? Now, what you say to the retriever is said, take 5 sentence above, take 5 sentence below, also include while before sending it to the LLM. And this is what you call it as a sentence window retrieval. You increase the window of the sentence. So now that retrieve content, whatever you had, let's say it is just 3 lines, because you have increased the sentence window, now it will look around 8 to 9 lines. Now because it is looking into a broader context, more context, better answer, and this is what you see. Earlier it was 0.27, now look at the context relevance. It's 0.4, that means it has got more context now. More context, better, more confident, better answer, right? Because the context relevance has increased, groundedness has also increased. Because the groundedness has increased, answer relevance has also increased, right? So you see, like how do we evaluate RAGs, right? We can't just take up this particular number and then send it to production. We have to look into those RAG triads, understand those values. What does those values imply? And then take up a call accordingly, right? Auto-merging retrieval, that's another technique, right? What is auto-merging retrieval? Now, again, a very beautiful concept. Think of it, you have asked a question, right? And let's say in this page, let's say there is a page where it has 4 paragraphs, right? In the second paragraph, it has found 3 chunks that are important. It has found out 3 chunks. And in the third paragraph, it has found 1 chunk. In the ideal scenario, it will just take up these 3 chunks and that particular 1 chunk and then send it to LLM for generation. But what we say is that if the number of chunks R3 out of the bigger chunk that originally, let's say this bigger paragraph, it was divided into 4 chunks. But when you did the query, these 3 chunks got retrieved. I would say, no, don't send these 3 chunks, rather than send the entire paragraph, right? And because it has just retrieved 1 chunk, only 1 chunk will go. So as a result, you understand now you are sending the entire paragraph and that 1 chunk instead of individual 3 chunks. As a result of it, now see the context relevance. Auto merging, it's increasing now, 0.55, because it has increased 0.95 and 0.85. Now we are confident enough that, okay, our RAGs are good enough to go to production. And this is how you evaluate. You just don't put it to production, and we would rather evaluate on it, right? Again, I would wait for 2 seconds. If you want to click a picture, work out on the experiments, you can scan it here, and you would rather find out like all the experiments that we have done. Okay? And finally, some RAG optimizations. I talked about sentence window. I talked about auto merging on the 2 RAG optimization. There are a lot of optimization that you can do. I have talked about 2 of the advanced retrieval optimization. Ajinkya has talked about re-ranking. So just look at this, right? The more you go towards the right side, better the answer, but more money and higher latency. The more you come towards the left side, quicker, less money, but lower accuracy. So it's a trade-off that you have to put up before you go to production, right? These are the things that you need to consider, various other things, right? Now, there are other things like LLM agents that you can also deploy, which Venkatesh will talk in detail about it, right? But I hope you could take some chunks out of it and you would rather use it while putting this before production. Over to you, Venkatesh.
Hi everyone, good evening. Thanks Suman for talking us through some of the nuances related to the production challenges. He basically ran you through the evaluation metric and how you optimize them, right? Now let us talk about the LLM agents. So before we get into like LLM agents, right? Why LLM agents are needed? First, let's understand that. So what are some of the problems or the pain points with the LLMs, right? So of course, we spoke about the hallucination and all. So one of the first thing that we will talk about is it can answer only based on the data that it is trained on. And second one is it does not have the access to the utilities like calculator. For example, if you ask a question like what is the answer to the 4.1 to the power 2.1, then the answer it gives, this is with the GPT-4, okay, 17.81, which is wrong. You can check, answer is 19.357, okay. So the reason why that happens is it does not have like, just like the humans, if you are considering, what you do is when you come across slightly, moderately complicated mathematical operation to be done, what you do is you get the access to the calculator and perform the operation, right. So, but what it does is basically the way the LLMs are trained, then it would have memorized the mathematical operations, right? And another thing with that is the way it processes. It is meant for language modeling. So it goes with the sequential processing. That does not work for the mathematical operations. So because of these two problems, it failed in that case. And another problem is it does not have access to the web. So if the model is trained on the data till, let us say, 2021, if you are expecting it to answer on some question that is, let us say, very recent events, then it won't be able to answer that. Yeah. So what are LLM agents? Whatever problems you saw in the previous slide, basically it enables the LLMs to be able to do those kind of tasks, right? So for a while, assume that put humans into LLM, okay? You don't have the calculator, just the example that I gave, and someone gives me the moderately complicated mathematical operation to be done, then I take the calculator and perform it. And someone asks me like information that I am not aware of, I get the access to the web, I do the Google search, and I get it, right? Now, in case of like LLM, how it works, let us understand. So LLMs are basically, agents are basically LLM powered knowledge workers. The way it works is, in its true sense, like LLM, you have the input, you have the output. But agent is basically, it is an LLM that is basically it is given a prompt to perform certain set of actions when it is provided with set of tools. So basically tools are your like a standalone functions. Like it can be like a calculator, it can be like a like access to the Google search, and toolkit is basically set of all the tools that are meant to perform the similar task. Okay, and agent executor is basically your agent and tool, they cannot run on their own. You need a runtime, right? That's where agent executor comes into the picture. So what are some of the LLM agents? We have been talking about like LangChain, Llama Index, Haystack and all. All of these frameworks do provide some of the agents. For example, let us say you want to build a programming assistant bot, right? What you need for that is like basically Python, let us say for the Python language, Python agent, because Python agent is the one that helps you to execute the Python code generated by LLM. Without this agent, you won't be able to like evaluate the code, execute the code, whatever you want to do, right? Now let us talk about another scenario where you are building a bot to generate the code in pandas. The query is related to some pandas data frame operations. Then what you need is pandas data frame agent and Python agent, because whatever code is generated for the meant for the pandas, you want basically that code, you need the Python executor for that. That's where you need the Python agent as well. Now let us take a look at, basically there are some example platforms that provide the agents. These are of course paid services. This one is by Abacus AI. So if you want to build a something like programming assistance tool, right? This is how system will look like. Basically you have like AI agent that is provided with the code executor, which is the AI, that helps you with the execution of, let us say, for example, Python code. And then, of course, there is like data that you can query to. There are a lot of LLM models that you can have access to. And another interesting thing is, while working with the code, let us say you want to perform optimization operation, anything of that sort, you can have access to the ML models as well. With this kind of ecosystem, you will be able to basically build a programming assistant sort of tools. So this is another interesting proposition by, basically there is a Floatbot AI who came up with this concept called master agent. Basically your LLM master agent acts as an orchestrator for your different LLM agents. Let us say there's a very big application, enterprise application that you are working with, and some of the various applications that come under this big applications are, let us say, there is a bot meant for the sales, help desk, and customer service, right? You want the utilities or the functions that help you to do, let us say, for example, CRM, ERP, or you may want to do the question answering on their PDF data. So for all these things, you need the different LLM agent, and the master agent acts as orchestrator for that. So moving on from the LLM agents, there is a concept called multi-document agents. So this is from Llama Index. We have, so far whatever we have been talking about, the entire RAG setup, we are talking about basically, let us say, you upload the documents, you want to build the bot, and there is a vector database, you query and get the response. How about, let us talk about the scenario. There is a large data set, and you want to do the QA on one specific document. That is one use case. Another one could be, maybe you want to do the QA on the summarization that is generated for these documents. And let us say, maybe you want to compare two different documents. Okay? And another use case could be, there is a summarized version of the documents and you want to compare the two summarized versions of the documents. If you want to perform any of these, all four of these, right, with in its original state with the just RAG setup, it will be very difficult, and by difficult I mean you won't be happy with the responses that you get, right? Let us take an example of like, let us say there are documents that are created for various cities in India. Let us say document 1 is for Pune, document 2 is for Bangalore, and so on, Hyderabad and Chennai. Okay? So it has all the content related to these cities. Okay? Now, where LLM agents help you is basically because you want to perform the tasks in such a way that, let us say my query is, can you compare the startup culture in Pune and Bangalore, right? If you have single document that is created with all the data that includes about all the cities in India, then the response you will get out of that, you won't be happy with it. Because if you are expecting in a summarized fashion, right, you have the dedicated LLM agents here that are meant to do, for example, like there is a document and it directly, if you see, it is stored in the form of object index, and these two basically they are doing summarization because that's what I want. In some cases, I am just comparing few things between two cities. In some cases, let us say I give another question. Can you basically compare and summarize the food options between Chennai and Bangalore, let us say, right? So for those kind of problem statements, basically multi-document agents is what you need. Now, so whether it is to do with the LLM or any LLM based applications or when you are working with the RAG, right? One of the most important thing is basically how you analyze the cost, and of course how you optimize for that. Of course, like before this, like people have spoken about fine tuning, and beyond that, let us see what are some of the methods, right? So of course, like if you are using the OpenAI's APIs, right? Once in a while, you will be happy with the cost, and if you are working for a company like Sahaj, you will get the reimbursement for that. And let us say if you are exhaustively using it on a daily basis, right? Your cost can be more than your AWS costs. Let us say I'm using it for some bot for 24/7, right? So that's why it is really important. These are like really expensive stuff. You have to do the cost analysis. So when we talk about cost analysis, basically it happens in three parts. One is cost of initial setup and inference. What I mean by that is basically expenses that are associated with storing the models and basically running any cost that is involved in making the predictions, right? That is basically initial setup and inference cost. And cost of maintenance is basically, let us say you want to improve your models on the custom data that you have. Then you want to be able to do the fine tuning training. So for that you need the labels. So there is a cost involved in whether you use the third party platforms for that or you use the human annotators, it always comes with the cost, the entire data labeling task. And then there is of course cost involved in fine tuning and deploying of the new model. Okay. Then other associated costs, for example, you all are aware of the CO2 emission, carbon footprint that these models generate. That is another cost. And another interesting one could be human resources, right? The whole world of the way the entire spectrum of the LLM is so fast-paced that every day there are like publications, research is being done, right? So for that, what happens is if you want to build application that requires, let us say, some of the state-of-the-art techniques, then either you need to train your people, there might be a training cost involved, or you want to hire somebody who is basically aware of that, who can quickly build it. So it is a cost associated with the human and skills, right? Now first let us talk about cost of initial setup and inference. So I will be taking you through two APIs, one basically third-party APIs, one is as you know by the open AIs, and if you see there is of course cost for input, that is the cost that is involved in generating your prompt or input token, and there is a cost for output, and some of the APIs like Cohere, they have the cost per request as well. So you should be aware of in some cases, let us say you are happy with the results of the Cohere, then of course you should be evaluating it cost as well. You are basically it is generating the per request cost as well. Now everyone will basically, we all will think like in many cases, if we want to do some simple to moderately complicated stuff, why to make use of and third-party APIs, right? And why pay for that? Why not have the basically host the LLM models on premise, right? That's what you will think of. So one of the major thing is when you are working with LLMs, if you are working with 3 billion parameters or at max 7 billion parameters, as long as you have a decent hardware, of course you can host it locally. What about like 30 billion, 70 billion, right? Then of course you will go for the cloud. And if we are to talk about the cloud instance cost, right, it can start from $0.6 per hour and go up to basically $45 per hour for the 8800 NVIDIA GPUs. That comes with a massive 640 GB GPU RAM. Okay, so the decision making will be how you can decide is you will be aware of number of the parameters that it comes with. Based on that, you know that where it goes. So if you have to compare, for example, let us say you are working for your application, you need a model that comes with, let us say, 70 billion parameter. So you have to do the cost analysis, compare between, eventually no point in, like let us say yourself hosting that model on the cloud and you end up spending more than the third-party APIs, no point in doing that, right? But unless and until, of course, if you are building an application for some of the clients that don't want to use the third-party APIs, maybe they are working with some classified data, want to host the model themselves, right? Now let us talk about cost of maintenance. Here, basically, when we, as I said, cost of maintenance is like cost behind fine-tuning or training your models. First one is by Vertex AI, AutoML models. It includes the 4 components, basically. First one is when you want to fine-tune or train the model, you need the data. So they charge you for the uploading as well, beyond, of course, first 1,000 pages. Until then, it is free. And then there is a training cost, there is a deployment cost, and when you put it into basically to do the inference or run the prediction, there is a prediction cost. Cost structure of like this is for the OpenAI's APIs, slightly different. Here they don't charge for the upload. Of course, they do charge for the training and input usage and output usage, right? Now, let us do the comparative cost analysis between, let us say you have a scenario, you want to build some simple applications, you want to decide whether I should go for fine-tuning or RAG. Of course, Shruti did speak about employing both as well, but I am talking about, I have these 2 options and I want to select one of them based on the cost because I have this much budget. How can I plan for that, right? If you see, the first thought that comes to you is like RAG, or like why fine-tune, it can get, it can be costly, right? But it really depends upon, I have taken this example, let us assume you are working with like 10 million tokens. It could be across, maybe you are building a conversational agent. Across many conversations, there is a 10 million tokens. And let's imagine you are running this for 15 days in a month, right? And what is the total cost? Basically, when it comes to fine-tuning, you have 2 components. One, the cost behind LLM model or embedding model. And of course, you multiply by like whatever tokens you are working with, and you get the cost for that. And then compute power cost, I'm doing 15 into 24 because I'm assuming like it is running for 15 days in a month. And total cost is sum of that, which is $250. And in case of RAG, what happens is, of course, there are vector databases that are like free. You can use them, and both of them, paid one and free, they all come with the pros and cons. I'm imagining, let us say I'm using the Pinecone, which its cost is $70. But here the major difference, if you see with the RAG, what happens is the cost mainly the $437 that you see on the right side, it is coming because of the output tokens, right? Because when you are working with the RAG, there is a cost associated with the input tokens or the prompt or the output tokens that is generated. Because of that, if you see the entire total cost, that is like $723, that's why. So here the point is, there is no like universal answer like cost-wise fine-tuning is better or RAG is better. It depends on the underlying task, it depends on the kind of the LLM model you are using, it depends on the number of the tokens, kind of the application you are building, where let us say conversation just ends in 2 to 3 like conversation between bot and human, or in some cases it can go up to like 100 to 200 conversation. Difference is mainly the tokens that you are working with, right? Now, this comparative cost analysis, if it is done across different LLMs, what is the, so we have seen that for like basically cloud model where the like, for in case of RAG it was $723 and in case of like fine tuning it was 251. But if you compare GPT 3.5, they are almost close. And let us say you are using a free vector database, then RAG will be lesser than, cost behind RAG will be lesser than fine tuning. So that's what I meant by there is no single answer which is better when it comes to cost. Now let us talk about cost optimization. There are various approaches. I think 3 of them are like already covered. Prompt engineering, caching with vector stores, I think Sibin and Karthikeya spoke about it. Fine tuning covered by Shruti. So chains for long documents, this is like if you have worked with a long chain, basically I think while coding Ajinkya showed retrieval QA chain. There are like multiple chain like concepts that LangChain provides. If you have worked with Apache Hadoop, right, you must be aware of basically map reduce, map re-rank, and refine. So it is a similar concept that they provide the like chain. And what I'm going to focus on is basically summarization for efficient chart history. So imagine you are building the conversation agent where you want the context to be maintained across the conversation, right? Because human is asking a bot and after a while he refers to something that he would have asked 10 minutes ago, right? For that, to be able to maintain the context, you need basically chart history to be appended with the context that you are aware. The problem with that, what happens is, as you move forward with the conversation, then the token size keeps increasing. And if it is, let us say 2048 is your token length limit, then after that you will lose the context, right? That's a problem. So yeah, one of the ways to basically solve it is conversation summary memory. This is the like memory class that is available from the LangChain. And usual case, what happens is you do the conversation buffer memory, where you will come across the problem that I explained. Basically, you will hit the token length limit, and because of that, you will lose the context, right? What happens with the conversation summary memory, right? Basically, before appending the chart history to the context, what it summarizes it and then appends. It makes sense when you are having the long conversation. It may not make sense if you are like, let us say, just doing hi, hello, good morning. Summarization may come up with more tokens than the actual summary, right? So this is the way you can initialize the basically conversation summary memory in LangChain. And let us see this example, right? What I explained earlier, conversation summary memory. So your current summary is, I'm not sure whether people in the back can read it. Current summary is, let us say human asks AI what it thinks of artificial intelligence, and AI thinks artificial intelligence is force for good. So next the conversation is human asks, why do you think it is a force for good, right? It says because AI will help humans reach their full potential. If you see new memory, it is like properly curated. It is not like just it appended to that answer, right? So that's where it reduces the token length, because it is like properly curating that answer for you. But still there is a issue with this approach. What is that, right? Even when you use the summarization, of course, just that compared to the regular approach, you may not lose to begin with context, but after a while still you will lose the context. What is the solution for that? It is basically whatever solution is offered by RAG pipeline to the LLMs, right? Through the vector DBs. You do the same with the chart history, right? You generate the embeddings, put it in the vector database, and whenever there is a current conversation going on, then you generate the embedding for that, and then basically you query and get the response. I think, yeah, this we already discussed. Yeah, so what the interesting point that I wanted to show is, if you look at that graph, right, the one in blue is like, it is better to begin with, because summarization is not efficient when you are talking about conversations in the beginning, because to be able to summarize, you don't have much of the data. It is just like formalities. You are saying hi, hello, good, stuff like that. But as you move forward, right, of course, in normal cases, which is conversation buffer memory, it linearly grows. So y-axis, you have the tokens per call, and x-axis, you have the number of the interactions. But as you move forward, like let us say 50 conversation dialogues or even 70, right, the summary memory turns out to be better than the buffer memory. Now, let us talk about the latency and throughput analysis for RAG or LLM. So, 4 important metrics that are at play here when we talk about like latency and throughput. Is basically, first one is time to first token. Basically, if you have used the ChatGPT, whatever that initial delay when you ask a query, it's, let us say you are asking like you are giving a 2000 word input and asking it to summarize it, and it starts generating the response, right? Whatever that initial delay time is there, that is the time to first token, okay? And basically it is time taken for model to process the prompt before it generates the first output token in technical way. So time per output token is basically, it is the time to generate the output token for every user that is querying our system, okay? The latency is basically time to first token plus time per output token into the, I mean, you multiply by the number of the tokens that need to be generated, that are part of the response. Throughput is basically rate at which you generate the output tokens. These 4 are really important when you want to talk about, basically you want to get the best possible inference speed, right? So what is our goal when we are working with the LLM serving, right? We basically want to generate, we want our model to generate the text as fast as possible for all the number of the users that we want to support. But there is trade-off between, when we talk about this, there is a trade-off between the throughput and time per output token. What I mean by that is, let us say you talk about concurrently supporting 16 users, then if you do that throughput wise, you will be better, but you will lose on the time per output token. So there is a trade-off between those two. Some of the useful heuristics. This is based on, if you understand this stuff, then it will be very easy for you to understand this. The first one, if you read out, output length dominates the overall response latency. What I mean by that is, when you calculate the latency, it has hardly has anything to do with the time it takes for the input token, right? Because it is mainly driven by the second factor that you would have seen. It gets multiplied by the number of the output tokens, right? So that is the one that decides the response latency. And input length is not significant for the performance, but it decides the hardware requirement. Let me explain this. So why I say it is not significant for performance is, in case of latency, the second factor which involved the multiplication, that mainly decides it. Basically output token, number of the output tokens to be generated, and time per output token, right? When it comes to throughput, it is anyway not dependent on the input token. It is the rate at which output tokens are generated. So that's why it is not significant when we talk about performance, but why it affects the hardware requirements, right? So each of the LLM, they all come with the limit on the context length of the token limit, right? That they can support. The moment you keep on increasing the input length, then it directly affects the context they can maintain. What you do is, to be able to solve that, you may use the bigger model or the models that are trained with a better number of parameters. That's where you will you need the better hardware to be able to support in terms of memory and compute cost. The last one is basically overall latency scales sublinearly with the model size. What I mean by that is, basically your speed ratio is, it does not match the parameter count ratio. Let us take the example of Llama 2 and MPT model. So in case of Llama 2, Llama 2 70 billion, the latency that you find in Llama 2 7 billion parameter model is X, let us say, and 70 billion is 2X. This may not be true for if you take some other model, 7 billion and 70 billion versions. So that's what I'm trying to convey here. So this is like we all spoken, so far we did speak about cost and latency analysis, but how to do it, right? So there is a open source library, LLM analysis, which helps you with basically five things: latency, throughput, time, then the memory, okay? So its main capabilities is basically, it helps you have the platform to try out the different combinations when you are working with the training and inference, okay? So theoretically only you can find out these things before you go and put the things into the production, right? Because you want to understand if you are going ahead with some setup, whether is it going to lead to the out of memory error or not, stuff like that. And when you are working with a like production grade environment, of course you want the best possible batch size you want to use, because you want to ensure the peak hardware utilization, and you want to use the right data type, whether it is FP16, int8, stuff like that. And it also helps you with the time it takes basically for the given setup, whether to do the training or inference. And of course, as I already said, it helps you with how the latency and memory changes depending upon those parameters. So this is one table that explains these things, how the LLM analysis tool or a library is able to do. The meaning of flop efficiency is basically your hardware utilization. Literature or the researchers found that in case of training, it is 0.5 for the when you are working with LLMs, and in case of inference, it is on an average 0.7. Basically, that is the 70% utilization of your hardware or GPU. That's what it means. Memory efficiency is basically how efficient memory reads and writes are happening between your DRAM, CPU, and GPU. Because compute is going on GPU or CPU depending on what you are trying to do, and then the weights are present in the DRAM. So the memory efficiency, once you make these assumptions, right, the LLM analysis tool gives you, let us say you select the prompt token, completion token, it gives you rest of the parameters, right? Based on that, you know the latency, you know time for completion is like basically through, so tokens per second is your throughput, and then time for completion is your latency, then it is helping me with the price as well. If you see basically compare two things, right? If you want to know what is the right batch size for me, you can do this kind of analysis using that tool. Okay, I think this is just whatever I wanted to cover, the most important part. So far it is done. It is just, I want to show one thing to you people. Throughout this day, more or less, whatever we have covered, they all belong to some of these things. So it is your LLM orchestration. For example, just to give one example, there is a tool, cost tracking tool by Aprio AI. What it helps you with is, let us say there are some anomalies associated with the cost. You are running your application across the globe and it is hosted, and let us say there is a sudden spike in price. Maybe there are sudden increase in the number of the requests raised. I'm talking about beyond like something that can be easily found, but with respect to like, let us say the consumption of whether it is LLM in terms of compute memory, then that tracker tool will help you to do that, which is basically part of your monitoring or observability. Yeah, I think, yeah, this is just, we have spoken about these things. Yeah, thanks. If you have any questions, please let us know.
Thanks, Venkatesh and Suman, for giving us insights on the practicalities of maintaining LLM on production. We will take questions now.
This is a question to Suman's conversation around evaluation metrics. The metrics revolved a lot around the inputs that we use to gauge what the triad values would be. But how do we gauge whether those inputs that we're using are going to be something that is going to be substantially close to
Can you repeat the question and a bit louder, please?
I'm sorry. The evaluation metrics revolved a lot around the inputs that you use to gauge the triad values.
Correct.
How do we understand whether those inputs that we use in the first place is something that would be very close to what we expect to see in production?
Okay, okay. I'll give you the answer in two parts, right? One, when you talk about the input values or the input questions, right? There is a research paper which I'll try to put in those GitHub slides as well. Ideally, it says that whenever you want to put LLM to production, if you are doing a good research, it's always good to have around 20 questions for your evaluation at the very first stage, right? In order to have a more concrete answer to whether your LLM is or your RAG is good enough for production, it is always advised to have around 100 evaluation questions. Now, how do you do that? There are two parts to it. Either as a human, if we are not very good enough knowledge about the domain that we are working up in. Let's say you are working on a healthcare domain. You are working on a kidney patients or kidney dialysis. You have a document out of it. You are a domain expert in kidney dialysis expert. You will find out a list of 100 curated questions all by yourself, and then you will put up those 100 questions to RAG threads to give you an answer, right? Else, what you can do on the other part, which I have also done, is take these questions or give this document to GPT-4, ask it to generate questions for you along with the answers. That's an automated way of doing it, right? One is the automated way actually will give you the answer, but then there is no way to rationalize those questions and the answer. But if you are a domain expert, let's say in kidney dialysis, you know what are the things that people may ask or what are the relevant questions. You would rather curate those set of 100 questions, take these questions to a TrueLens, which does an RAG triads. It will give an answer, and also with those answer relevance, context relevance, and the groundedness, you will look at the answer. If you go to the TrueLens package, it will give you like what was the answer, what is the score, and why did it give the score. You can get a detailed RCA or root cause analysis, right? You can actually find out that, okay, maybe this was the answer that was given by the LLM, but actually this is not the answer. It did not get the context. And when you find out those answers, you become more and more confident enough that, okay, my RAGs or LLMs are good enough for taking this to production. So to answer to your question, two ways. Either you do it, if you are a domain expert, do it by yourself, curate 100 list of questions before you go to production, or you give it to GPT-4 to generate those questions, and the rest would be taken care of.
I have two follow-ups.
Sure.
If I have the time for it.
Yeah, please go ahead.
So my concern is that in a real life use case, context relevance from the end user side may not really be high because they are not domain experts usually, right? Like they may or may not be domain experts, and their natural language is not going to be something that associates to our source input in the first place.
Okay.
We'd have to design for those kind of use cases as well. And how do we even recognize those in the first place?
Now, good question. So there, I look at it in two ways, right? Either you are building up an application which is life critical. In those cases, you will not give to a generic user. You would rather take up a domain expert who would rather, like if I talk about the kidney dialysis, I would not depend upon some person who doesn't have much idea. I would rather bring in or loop in that person who is a domain expert for those kidney dialysis, who knows the entire domain end to end, ask her to read the document and generate a list of 100 questions. In case of a normal, let's say, I'll give you another end of the spectrum. Let's say you are building up a customer service bot, or let's say in Flipkart or for a particular product, you are building up an FAQ, right? So for FAQ, you do not have to be so critical about those answers. In those cases, you can actually take up one particular generic user or a particular employee to say that, find out a list of those relevant questions and put it up, right? In those cases, you have to decide upon what is more important for you. If these are life critical applications that you are building, you have to be very cautious, right? Kartika showed a slide where ChatGPT gave 83% of the wrong predictions. This may be fatal for users who have just got admitted into a hospital. For those cases, you can't take risk. But for building up an application which is customer centric, like building up a FAQ or a customer service bot, these are not life fatal decisions, right? For those, you can choose up accordingly. So it depends on what are you building upon.
Right. So do we have any concept of tooling around observability for these usage, like these questions that actually come into the system? I know we have observability around tooling and like what our costs are, etc., but very much focused on what kind of prompts we get from users and how we respond to them, what the success ratio over there is, etc.
Ideally, there is no one such rule or no one one-centric rule. It's all about if you have this particular domain analysis, you have to understand what the user might ask, right? If I talk about, let's say Flipkart, a dishwasher, 12-plate dishwasher, I might, the first question that comes to my mind, what is the dimension of it? That's the question that comes as an user, right? What is the dimension? I have a 3 BHK house, I want to slide it near my washing machine, what will be the size of it? Or how many plates can it wash? Can I put normal detergent on it? These are the questions that you know beforehand. But on the other side, on the domain-centric, where specifically for the kidney dialysis, you know user might ask very specific question.
Sorry, just clarifying, this, what you're talking about now is before you productionize. I'm talking about observability after you do.
After you productionize, ideally, as I said, like there are various monitoring tools, LLM monitoring tools that you can employ. Put those numbers, so take out, so ideally even in ML pipeline, what we do is that every fortnightly we take up a part of the chunk of the question that users have been asking regularly. We take up a part of the chunk of the questions, put into one of the evaluation pipeline, right? So let's say TrueLens has been deployed in one of your remote test server, and you keep on evaluating those part of the question, a chunk of the question. Over time, if you see that the context relevance value goes down from 0.55 all the way to 0.39, then you understand that the context that it might want to generate specific to the user query is decreasing. You put up a threshold saying that, okay, we might have to generate more relevant questions, or we might have to put in additional information to enhance the performance of the RAG. And that's how you do it, right? There is no one first rule. You can either choose to deploy it, and then like whenever user says, hey, it's giving up a wrong answer, you then take a measure, or you may take a proactive measure, take a part of the chunk of the question, put those part of the chunk of the question into a test pipeline every fortnightly, and check the performance, and then come up with proactive measures to deal with it. That's how we would rather deal with it. If you have better suggestions, please let us know.
No, thanks, that's pretty good.
Thanks, Venkatesh and Suman.